But even here on Earth, there's a chance we can detect evidence of strings. This pasture in Illinois serves as command central for a lot of this research. Well, actually, the real work happens underground, where the hunt is on for evidence supporting string theory, including extra dimensions.
Not too many years ago, people who talked about large extra dimensions would have been considered crackpots, to put it lightly.
But all that has changed thanks to string theory. This is Fermilab, and right now it's our best hope for proving that extra dimensions are real. Fermilab has a giant atom smasher. Here's how it works. Scientists zap hydrogen atoms with huge amounts of electricity. Later, they strip them of their electrons and send the protons zooming around a 4-mile circular tunnel beneath the prairie. Just as they're approaching the speed of light, they're steered into collisions with particles whizzing in the opposite direction. Most collisions are just glancing blows, but occasionally there's a direct hit. The result is a shower of unusual subatomic particles. The hope is that among these particles will be a tiny unit of gravity, the graviton. Gravitons, according to string theory, are closed loops, so they can float off into the extra dimensions. The grand prize would be a snapshot of a graviton at the moment of escape.
And then the graviton goes to the extra dimension, and then it shows in the detector by its absence. You see it by its absence.
Unfortunately, Fermilab hasn't yet seen the vanishing graviton. And the pressure is on, because another team is hot on the same trail. 4,000 miles away, on the border of France and Switzerland, a lab called CERN is constructing an enormous new atom smasher. When it's finished, it will be 7 times more powerful than Fermilab's.
There's a great sense of urgency that every minute has to count, but eventually CERN, our rival laboratory, will, frankly, blow us out of the water.
CERN will blow Fermilab out of the water not only in the search for extra dimensions, but other wild ideas. At the top of the to-do list for both labs is the hunt for something called supersymmetry. That's a central prediction of string theory, and it says in a nutshell that for every subatomic particle we're familiar with, like electrons, photons, and gravitons, there should also be a much heavier partner called a sparticle, which so far no one has ever seen. Now, because string theory says sparticles should exist, finding them is a major priority.
So it's a big discovery to find supersymmetry. That's a humongous discovery, and I think it's a bigger discovery to find supersymmetry than to find life on Mars.
If we were to hear tomorrow that supersymmetry was discovered, there would be parties all over the planet.
The problem is, if they exist, the sparticles of supersymmetry are probably incredibly heavy. So heavy that they may not be detected with today's atom smashers. The new facility at CERN will have the best chance once it's up and running in several years. But that won't stop the folks at Fermilab from trying to find them first.
The competition is friendly and fierce at the same time. We're competing like bad dogs, essentially. And it has always been like that, and it will always be like that.
We have to make sure that we don't make any mistakes, that we do absolutely the best we can do with these experiments, and take advantage of what is really one of the great golden opportunities for discovery.
If we do find sparticles, it won't prove string theory, but it will be really strong circumstantial evidence that we're on the right track. Over the next 10 to 20 years, the new generation of atom smashers is sure to uncover surprising truths about the nature of our universe. But will it be the universe predicted by string theory? What if we don't find sparticles or extra dimensions?
What if we never find any evidence that supports this weird new universe filled with membranes and tiny vibrating strings? Could string theory, in the end, be wrong?
Oh yes, it's certainly a logical possibility that we've all been wasting our time for the last 20 years and that the theory is completely wrong.
There have been periods of many years where all of the smart people, all of the cool people were working on one kind of theory, moving in one kind of direction, and even though they thought it was wonderful, it turned out to be a dead end. This could happen to string theory.
Even though there's no real evidence yet, so much of string theory just makes so much sense. A lot of us believe it's just got to be right.
I don't think it's ever happened that a theory that has the kind of mathematical appeal that string theory has turned out to be entirely wrong. I would find it hard to believe that that much elegance and mathematical beauty would simply be wasted.
I don't really know how close we are to the end. You know, are we almost there and having the complete story? Is it going to still be another 10 years? Nobody knows. But I think it's going to keep me busy for a long time.
We have been incredibly lucky. Nature has somehow allowed us to unlock the keys to many fundamental mysteries already. How far can we push that? We won't know until we try.
A century ago, some scientists thought they had pretty much figured out the basic laws of the universe. But then Einstein came along and dramatically revised our views of space and time and gravity. And quantum mechanics unveiled the inner workings of atoms and molecules, revealing a world that's bizarre and uncertain. So, far from confirming that we had sorted it all out, the 20th century showed that every time we looked more closely at the universe, we discovered yet another, unexpected layer of reality. As we embark on the 21st century, we're getting a glimpse of what may be the next layer. Vibrating strings, sparticles, parallel universes, and extra dimensions. It's a breathtaking vision, and in a few years, experiments may begin to tell us whether some of these ideas are right or wrong.
But regardless of the outcome, we'll keep going because, well, that's what we do. We follow our curiosity. We explore the unknown. And 100 or 1,000 years from now, today's view of the cosmos may look woefully incomplete, perhaps even quaint. But undeniably, the ideas we call string theory are a testament to the power of human creativity. They've opened a whole new spectrum of possible answers to age-old questions. And with them, we've taken a dramatic leap in our quest to fully understand this elegant universe.